Good morning, Sean here, Mountains Garage, with a continuing video series in more detail than ever before of assembling a TH475 race transmission. Today's goals are to assemble the front pump, to show you how to mark out the case if you need to drill extra bolt holes, and we're going to install the BTE SFI Bellhousing. Let's take a look at the parts laid out in front of us. Normally when I'm overhauling a transmission, the pump hasn't been sitting abandoned full of water for decades. But today's 8-bolt pump that I chose is from one of the Swamp Monster HD Pontiac transmissions I stripped in a series of videos a couple months ago. I am many hours, I stopped counting at 12, into cleaning it between the rotojet, hand cleaning, ultrasonic cleaning, more hand cleaning, wire brushing, etc. But here we are, ready to use and assemble. The front half, an 895 casting, which the manual is excellent in telling you which pieces you can interchange. Like, for instance, the pump halves don't have to stay together, but they need to be properly matched. The pressure regulator parts change throughout the years. There's a few things you need to know if you're swapping parts. In this case, I'm keeping all the original parts together, so not much concern there. The front half I painted last week, so it's nice and dry. Today we're just putting a gasket against it when we install it. But if you just painted it and you're installing the pump bolts with the washers, it'll normally furrow the paint up. So if that's important to you, let it dry. It's just a nice condition now. Clean casting. I like the Made in USA Durabond bushings. They're inexpensive and they're one piece instead of having like the puzzle piece that connects the halves. If I do have a pump bushing with that puzzle piece that I'm talking about, if you look at the bushing you have and it's connected, I just like to put it at the top of the transmission when it's in the installed position. It seems to make sense that way. I don't think it matters, but in my brain it does. The seal today is Taiwanese, but it's fine. They're all kind of the same, I believe, even the ones from the name brand companies, if you will. The back half, I was at least halfway through the cleaning process before I was even able to free the pressure regulator. It was just stuck with mung more than rust, but it cleaned up. I actually polished it a little bit with some Scotch-Brite in the lathe and cleaned the bore out with a wire brush. I spent a lot of time working on the back half of the pump. Before I do any actual assembly, I'm going to cover what it takes to convert the pump from a 6-bolt to a 7 or an 8. And same with the case. If you're adding bolt holes, sometimes there's a little bit of setting up involved. So let's go over how I do it anyway. The rear section of the pump, 99% of the times has all 8 bolts. I'm going to save that 1% for some oddity that may have occurred along the assembly line, but most of the time all your bolts are present in the back half. So on the pump itself, you just need to align, mark, and drill the front half. And your gaskets are all 8 bolt as well, so no adaptation there. The gaskets are all the same. The back half of the pump is all the same, but you need to accurately mark and drill. I assemble the pump like, it's going to go together. I put the band around it, tighten the bolts, so both halves are together. Then I've taken a piece of 3/8 rod and I machine the outer so it's the correct size. It's hard to do this through the phone. Exactly in the pump half. And I have a 1/8 hole drilled in the lathe on center. So with the pump assembled, I can put this in the hole and take an 1/8 inch drill bit and just drill in and mark with the head of the drill exactly where the bolt hole needs to be. Then I can disassemble and finish drilling the front half of the pump. Very accurate. A transfer punch is good, but there's error. This is the tightest one I have, and I can still rock it back and forth which the little piece on the end, I'm just moving that back and forth. So you could be wrong. You can still use it, and you can try to hold it perfectly, straight up and down and mark it. I'm not saying that won't work. But for 10 cents and a little time, this little baby works really nice. This is the 475 case that I stripped, and it is very rare that it has what I call the 7th, because a lot of times there's only 7 bolt holes. This bulge will be here, but the 8th, there's no aluminum down here. They've removed it when they cast the housing. This boss doesn't exist. This is very rare that it has these two. Rare is the ones I find anyway. And this one is ready to be an 8-bolt case because they gave you the bosses. So I set the back half of my pump down in. I like to put all the bolts in because there's always some error. So once you get all the bolts in, you won't be able to rock. And even then, you can put it halfway to make sure it's fully relaxed. When I get the back half of the pump in the position I like, I'll take a couple bolts and actually tighten it up so it's held in place. Take the same drill fixture that I made, install it in its hole, and I'll just take the drill and touch off on both sides so I'm accurately marked. And then if you can, just get it in a drill press, sitting just like it is with the tail housing flange down so it's 90 degrees to the drill. And you can make the choice of drilling 1/4 inch for a 5/16 coarse bolt, or you can go right to a helicoil. Probably best to start just direct threading the case. That way you have time and opportunity for a repair in the future. You could use this as your drill guide, but eventually you'd probably waller it out and have to make a new one. Not the end of the world, but it's better than freehanding anyway. At least get the 1/8 inch hole started. Be careful of your depth. I measure a hole that's already drilled and figure it out somehow, mark it so I don't go too deep. I don't want a whoopsie where I don't want it, a hole. Removing the old stator bushings is always a challenge. It looks like you could just start from the other side and hook in behind it and push it out this way. Maybe you get lucky because the front one does not sit down on the step inside the tube, but it's pretty smooth. I actually have better luck using, this is a snap-on bushing remover. You could make that with a piece of flat bar pretty easy. Just find something, and I actually just use it this way, beat down on it, and it'll spin the bushing in its hole enough so you can pop it out with a screwdriver. I'm careful not to hurt the tube. I don't care if I wreck the bushing and it looks like this when I'm done. These aren't that bad, but they took a little bit of effort to get them out. Same story with the rear one. So I don't want to hurt this insert, but I do want a new bushing in there, so you just got to work at it gentle, and you'll get it. The service manual does not give any written description of how to do it, but I guarantee you if you had the original J tools, they have a shoulder on them that stop the bushing at the correct installed height. I made my bushing installer for this operation, and I've marked front and rear with those lines, if you can see the lines. So when it's installed, try to do this with 2 hands. My line is lined up with the edge, so I know I don't go too far. The rear one does sit against a little shelf, but this way, as I'm gently pressing or tapping down, I know when to stop and look anyway. If you have the return lube holes in your input shaft, a non-bush converter, all reasons you would need to run a stator bushing on the front of the tube, you could easily put it in too deep. So I have my mark and I just install it to that level because it does not sit on the shelf inside. If you have a bushed turbine converter, you can choose to leave out the front stator bushing and you'll get better return flow out of the converter, helping to alleviate thrust issues, etc. If you have a solid input shaft, you have to leave it out and you have to have a bushed converter. If you have a bushed converter, an input shaft that has the lube holes, you can choose whether to run it or not. I've drilled the converter charge pressure feed hole with a 5/16 coarse tap. You don't need to go down very far. You just need enough room to install below flush. A 5/16 set screw in brass is a lot easier to drill. The 1/8 hole in the middle. You can choose the size hole you want. 1/8 is pretty popular. I'm installing the pressure regulator spring that came in the transbrake valve body, ATD. And they say do not install the horseshoe shim. So just put it in with its normal parts. That stuff is going back in. Of course, I'm going to lube everything so it's not going to rust and it's not going to cause a problem when we finally put an engine in front of it and make some noise. If you need any guidance, it's clearly laid out in the book. I've mentioned this trick before, but here I am hands-free, halfway installing my pressure regulator valve. When I used to push it in by hand and try to get the snap ring in there, I certainly wouldn't be shooting a video. So this is for like a small engine or something. It's very compact. You wouldn't want to tackle a V8 Chevy with it, but in this case, it works perfect. Given the choice, because I examine everything, there is a round and a flat side to the snap ring. In this case, I like to put the flat side against the bore this way and the round part against the boost valve. This is me, although I have read or seen it somewhere else that somebody else had the same opinion. What I like about this valve spring compressor is I can just push the snap ring right over the rod and put it in there, so I don't need to worry about lining this up at the same time. I can just put it in, let go, done. And of course, everything's getting coated because I had brought this down to an absolute bare casting and left to sit around. It's going to rust. So everything needs to be lubed. On final assembly into the case, I'll clean the gasket surface so that is dry. Working on the front half now. I'm just going to take my installer, drive the bushing down until it stops. And because race car, I am going to put a little cylindrical part bonding on the surface right here. Just a little dabble do you. I don't do this when I'm building a stock transmission, but it gives me a warm fuzzy feeling when I'm building a race car. When I say a little bit, you do not want it to leak out onto your installed pump gears and have it dry solid overnight and have your pump stop turning because you got sloppy with it. So make sure before you put the pump gears in there's not any residue, or you might be sorry. Ready to install the front seal. As usual, I pack the inner cavity. Some of these have a visible spring that you could knock out by tapping on this seal. This one you can't see anything, but I just do it out of habit at this point. I don't get any on the sealing surface. You could, if you wanted to, take your finger and wipe some kind of sealer around there if you felt the need to. I don't. I just put them in dry. It's getting hard to do with the camera. And this is just a seal driver I made out of some random old service tools. Nice and flat. I just drive it in with the old rubber hammer. I went back and forth a couple times in the decision-making process of whether to put in new pump gears or use the old ones. The old ones turned this color during the vapor rust process. I threw them in with everything else. They would probably shine up again in service and be fine, but I decided to go with new pump gears. They're less than 20 bucks. These are old American made, I'm sure. These are unknown origin. Whatever. I'm going to put them in and run them. These both measure 0.727 width. If you didn't have the old gears, you'd have to measure down from this surface to the pump gear. And the clearance is 7/10,000ths to 2/1000ths. So roughly translated, they need to be a little bit below the surface of the front cover. The new outer gear, the big one, is not marked for direction. The inner is, and the lugs that engage the torque converter need to be as far away from the torque converter as possible. They need to be offset. You can see they're offset. When I take apart an old pump, I take my tiny prick punch and I mark the gear if it's not already marked. Sometimes the dot will be installed down from the factory. Either way, if you're reusing the gears, I always try to put them back in the direction they came from. The 5 bolts that hold the pump halves together are all distinctive lengths compared to the other bolts in a Turbo 400, with the exception of the one long one, which looks like a valve body bolt, but it's really shorter. So it's distinctive on its own. These two are the same. These two are the same. If you need to source new bolts, the book even tells you what you need. Inch, inch and a half, inch and 3/4. The front pump is now ready to install. In the position it's in, I set the back half over the front cover that was sitting on the bench, pulled them up, started all the bolts finger tight. Put my hose clamp arrangement over it, tighten the clamp, tighten the bolts on the pump. I immediately flip it over using this tool that I made. I cut a hub off a torque converter and welded a piece of pipe on it. If I was to do it over again, a replacement torque converter hub is slightly longer. My weld gets too close to the seal for my liking, but I'm careful and I want to make sure the pump bushing fits well and the gears turn. I installed a new pump O-ring and lubed it. I stuck the selective washer that we selected the other night for the end play in place using green assembly glue and also on the Teflon seals. And I lubed the bore in the forward drum where this is going to sit. Double check that the nail was still in the linkage. Put a new gasket in place. Ready to install the pump. The front pump is installed in the case. I used my 2 alignment studs, 2 regular pump bolts to help draw it in the last little bit, and I used 4 of the soon to be installed bolts that hold the BTE Bellhousing on. So I had a bolt in every position. Even with a bolt in every position, you can still move the pump a little bit either way. I want everything relaxed, and I used the 2 pump bolts to make sure it was all the way down. If you watch, you can see the seals go into the forward drum, and you can also measure your front end play there if you wanted to, but we already did that. So, and then I removed all that junk except the studs and installed the ATI gasket. If you watched the SFI Bellhousing install video last week, I'm not going to use the O-rings that came with the BTE housing. The O-rings would be on the back side of the bolts. You'd have to put the bolt through, put the O-ring on the bolt, and then assemble it all together that way. I've decided to use the ATI gasket instead. I think it's easier. I put it on dry. I had the bolts all prepared, each with a drop of Loctite and the washer and lock washer. And I will fill each depression all the way around, with the exception of the middle, with clear RTV sealer to seal the washers on the bolt when I install it. Hopefully that stops, because these are a direct line inside the case. I don't want fluid coming out around the washer, so it's okay to be a little messy, and I'll clean up my mess afterwards, because you know I don't like RTV sealer. I mean, I like it. It does a good job, but I don't like gobs of it. The BTE SFI housing is installed. In doing so, I'm officially launching a quest. I like the idea of using the ATI gasket between all 3 brands of housings, ATI, BTE, and JW. And in all cases, those 3 cases, the housings are wonderful pieces of engineering. I can't thank you enough. But it's like they got done engineering this piece and then walked down to the hardware store, maybe rode their scooter, and bought a bunch of hardware store junk to install it with. So what needs to happen, a high quality gasket, the ATI is just a piece of paper, $4. A nice thin high quality gasket to go between the housing and the pump, 8 flange bolts, not regular grade 8 bolts with lock washers and flat washers. That's not a big deal. We should be able to handle that. Find some flange bolts. And a structural washer that'll seal on the inside and not compress. You've seen them before. The metal got rubber in the inside that hugs the bolt to seal each bolt. So you don't have to fill these cavities with RTV and then pick it out afterwards if you care what it looks like. I don't want to leak, so I dealt with it this time, but I'm going to find a way to do it better. And I shouldn't have to. For the money you pay for these, they should be properly engineered from the installation aspect as well. That's my rant, and now I'm done with it. I think I'm getting a little bit hangry. Sorry I got a little salty there toward the end, but I will fix this problem. I want this housing to be easy on and off. Every one I've ever dealt with, regardless of brand or who installed it, it's a horror show. I want to be able to just bolt it on with no sealer required, not have it leak, and then be able to take it off, throw the washers and gasket away, fire a new one on it, and bolt it right back together. So that is my desire, and I'm going to make that happen, one way or the other. So like, share, subscribe, ring the bell, all that stuff. Next up is rear servo, valve body, modulator valve. I forgot about the tail housing when I was listing stuff off, so a few more items, and this thing is done. The pan, don't forget the pan, and a reusable gasket. So that's another quest that I have fulfilled. They're out there, and we'll go over pricing and my initial thoughts as I unpackage it and install it for the first time. So I've used the Moroso. That's a fine piece. I found a different one, but I'm jumping ahead. So I'll catch you soon. Later, bye.